Ever noticed how ice cubes just chill at the top of your drink instead of sinking? Most solids sink in their liquid form, so why is water the oddball? Normally, solids are denser than their liquids. That's why a rock sinks in water and a molten metal solid block would sink in molten metal. Think about it, a rock, which is a solid, sinks in water. A solid piece of metal would sink in its molten liquid form. Think of candle wax. When you light a candle, the melted wax pools around the wick. If you drop a solid piece of wax into that pool, it sinks because solid wax is denser than liquid wax. But water? It breaks the rule in style. When water freezes, its molecules arrange into a crystal lattice, like a neatly organized honeycomb. This is all thanks to something called hydrogen bonds. In liquid water, these bonds are flexible and the molecules are packed more closely together. But when water freezes, these hydrogen bonds lock the molecules into a fixed, hexagonal lattice. This rigid structure holds the molecules further apart than they are in their liquid state. This is all thanks to something called hydrogen bonds. In liquid water, these bonds are flexible and the molecules are closer together, constantly moving and rearranging. We see this life-saving property in action all around us, from our local ponds to the vast Arctic Ocean. In winter, ice forms an insulating layer on lakes and ponds. This protects the water below from the freezing air, allowing fish and other aquatic life to survive. But when water freezes, these hydrogen bonds lock the molecules into a fixed, hexagonal lattice. This ordered structure has more space between the molecules compared to when they were in a liquid state. Seals use the ice to rest and give birth to their pups, safe from predators in the water. Arctic foxes and other predators also use the sea ice as a platform for hunting. This structure keeps the molecules farther apart than in liquid water, making ice less dense. Less dense means it floats. Imagine a lake in winter. Instead of a protective top layer, the ice would sink. More water would be exposed to the cold air, freeze, and sink until the entire lake becomes a solid block of ice. Imagine a lake in winter. Instead of a protective top layer of ice, the ice would sink. More water would be exposed to the cold air, freeze, and sink until the entire lake is a solid block of ice. There's another huge impact. The vast white sheets of floating ice at the poles act like a giant mirror, reflecting the sun's heat back into space. This is called the albedo effect, and it's crucial for regulating our planet's temperature. If ice sank, this reflective shield would be gone. The darker ocean water would absorb more heat. This would drastically alter ocean temperatures and currents, leading to unpredictable and extreme changes in global weather patterns. This quirk of water is more than a party trick. It's life-saving. If ice sank, this reflective shield would be gone. The darker ocean water would absorb more heat. This would drastically alter ocean temperatures and currents, leading to unpredictable and extreme changes in our global climate patterns. But what if ice behaved like most other solids? What if it were denser than water and sank? This would mean no more cozy winter homes for fish. Aquatic ecosystems would collapse, and many species would go extinct. The consequences would extend beyond the water. The Earth's climate would be much colder, as the vast expanses of ice at the bottom of the ocean would not melt easily during the summer. So, the simple fact that ice floats is not just a cool party trick. It's a fundamental property of water that has shaped life on Earth as we know it. Ice floats, forming an insulating layer on lakes and oceans. That's why fish can survive under frozen water in winter instead of turning into fish popsicles. So next time you sip an iced coffee, think physics. Without floating ice, Earth's lakes would freeze solid from the bottom up, and happy hour wouldn't be the same. To recap, ice floats because water expands when it freezes, creating a less dense structure. A tiny molecular quirk with giant consequences for life on Earth. Stay cool with more fun science. Follow and subscribe for your next mini discovery.